Today let us see how to find the maximum or the minimum of any given quantity like area or volume of any two-dimensional or three-dimensional figure like circle, cylinder, sphere, etc. So this is our first question. What is it about? It is about a circle. The radius of the circle is fixed. Suppose it is r. Now I can inscribe any number of rectangles inside this circle, right? The question is, if I want the rectangle to have the maximum area, then what condition should it satisfy? Suppose this is the rectangle that I have inscribed in a circle. So if this rectangle was to have maximum area, what condition should it satisfy? Now the answer is in the question itself. What does it say? If the rectangle is to have the maximum area, then L and B should be equal. The length and the breadth should be equal, or in other words, the rectangle has to be a square. Now, do you see the significance of this topic? Do you see what we are doing here? We have taken two different shapes and we have tried to fit one inside the other in such a way that we make maximum use of the area. Clearly, this is used in the field of engineering to design a wide variety of items, starting from construction materials, electronic items, down to the toys and kitchenware. So it has a multitude of applications in your daily life. So that is why this is a very interesting and even more importantly, this is a very easy topic. So how do we go about it? So now we come back to the question. So what do we have here? We have a rectangle and its area is L into B. So you see the problem here? We have two independent variables. What are independent variables and what are dependent variables? Suppose you have a circle. So the area of the circle will be pi r square. Now r is independent. It can take any value it wants. But then A is dependent on the value of r. As r changes, A also changes. So you see the problem that we have here? Here we have two independent variables, L and B, and A is dependent on both of them. So what we do is we cut down the number of independent variables. So we keep one of them as it is. We take the other one and express it in terms of L, this one, and the original, whatever dimension that is given. We express this B in terms of L and R. So now we will try this with many shapes, with cylinders, cone, etc. But the basic idea is same. Whatever you have to maximize or minimize, write down its formula and try to bring down the number of independent variables to just one. That is what we will try to do in every question in this topic. That is what we will try to do. Now, how do we express B in terms of L and R? We will see that. Suppose this is the radius. If this much is B, what is this height? This will be B by 2. Why is that? Because both the square and the rectangle are symmetric shapes. So when we put the rectangle inside the circle, if you consider the diameter, the diameter will pass through, this particular diameter will pass through the line segment which joins the midpoints of these two sides and also these two sides. So if this is B, this will also be B by 2. Okay, and why is that? Because it is symmetric. And understand that it is the same if you have a cylinder, a rectangle, a square, a sphere, all of them is same. But then what is the only figure which is not symmetric? Do you remember cone? Do you remember how cone looks like? This will not be symmetric. So when we come to cone, we cannot take this shortcut. So this is B by 2. Similarly, if this whole thing is L, what is just this much? This much will be L by 2. Now what is this? This will be your radius. So what do you have here? Here you have the radius of the original circle, B by 2, L by 2. Apply Pythagoras theorem. What do you have? r square is equal to b by 2 square will be b square by 4 plus l square by 4. That will be multiplying throughout by 4, you get this is equal to b square plus l square. That means b square is equal to 4r square minus l square. So now do you see the problem we have here? This is b and here you have b square. If I were to take the square root, put it here, then when you maximize, what do? You have to take the first derivative and second derivative. It is going to be a big headache. So what I will do is, I will just square this. So area square will be L square and B square. And trust me, it will not affect the points where A is maximum. Whichever point where A is maximum, A square will also be maximum. So let us take this A square to be, say, Z. So Z is equal to L square B square. Now what is B square? We have found it here. B square is 4r square minus L square. That means it is 4r square L square minus L raised to 4. This is our Z. So what have we done? We have taken the area. It had two independent variables. So that is a headache. So what have we done? We have tried to bring it down to just one independent variable. And what are the others? 4 and r. R is fixed. 4 is constant. If you differentiate it, these values will not get affected. So let us find dz by dl. What is that? It is 8r square L minus 4L cube. Now to find the critical points. What are the critical points? Critical points are where dz by dl is equal to 0. So that means what? This whole thing. If you equate this whole thing to 0, what will you get? You will get 4L and inside you will get this. This is equal to 0. Now you have the product of two numbers which is 0. So either the first number will be 0 or the second number will be 0. So why can't the first number be 0? It is 4 into L. L is the length of a rectangle. How can the length of the rectangle be 0? So this cannot be 0. So the only option you have is 2r square minus L square is equal to 0. That means r is equal to L by root 2. Right? So now we have found the point. We have found the point where dz by dl is 0, or in other words, we have found the critical point. It is d square L by dl square negative. Only then it will be maximum, right? D square z by dl square should be less than 0. Only then we can fix this as the maximum value. So differentiating it once again, you have 12L square. But then what is r? R is L by root 2. So r square will be L square by 2. That will be 4L square minus 12L square. That will be minus 8L square. That means what? L square is positive, right? Any square will be positive. So minus 8L square will always be less than 0. Also we have the second derivative is negative. That means a square is maximum in this point. If a square is maximum in this point, then naturally a will also achieve its maximum value at this within this condition. So now we have only L here, right? We have to find what B is. So what is B square? B square is 4R square. That is 4 into L square by 2 minus L square is equal to L square. B square is equal to L square. So L is also root 2R. B is also root 2R. Or in other words, what do you have? Both L length and breadth are equal, or in other words, this figure is actually a square. And it is not asked in the question, but still I am asking you, what will be the maximum area? Area is L into B. We have found L is root 2R and B is also root 2R. That means 2R square. You have a circle, suppose of radius say 5. Then any rectangle inscribed inside this circle can have the maximum area, and that maximum area will be 2 into 25, which is 50. Now we come to the next question. What are the two shapes involved here? What is given? A sphere is given. What is its radius? Its radius is given as R. Now it is given. That means it is constant. You cannot touch that. It is fixed. Okay. So now we are going to inscribe a cylinder inside this sphere. And we want this cylinder to have maximum volume. For that, what conditions should be satisfied? Now, what is the volume of a cylinder? It is pi r square h. Did you notice that? For the radius of the sphere, we took small r. So, for the radius of the and did you notice that for the radius of the sphere, we took small r. So, for the radius of the cylinder, we have taken capital R. So, where is the radius of the cylinder? Where can we mark it? Here. This is radius of the cylinder. And what is the height of the cylinder? This will be the height. This whole thing will be h. And here will be the center of the sphere. And here will be the radius of the sphere. Now, what will be this length? This whole length is h. And then this will be half of it, which will be h by 2. Why is that possible? Because cylinder is a symmetrical shape. So when we take the axis of the cylinder, it will coincide with the center, and the center cuts that height into exactly 2. Remember, the cylinder, sphere, all of that are symmetric. So this happens with all of those shapes except for cone. It does not work with cone because cone is not symmetric. So now what is the problem we have here? We have two independent variables. We cannot have that. We have to bring it down to one independent variable. What do? We apply the Pythagoras theorem, which is this by h square by 4. Now, let me ask you one thing. You have two independent variables. Which are we going to keep as it is and which are we going to substitute? You see the problem with the Pythagoras theorem? You will only get the values in squares. You will not get it in h. You will only get it in h square. So then again we have to square this v. So we will not go into such complicated things. We will keep h as it is and we will substitute for r. Then what will you get? Instead of r, you get r square minus h square by 4 into h. So that means pi r square h minus pi by 4 h cube. So now, good news. What do you have? You have only one independent variable. Pi and r and 4 are all fixed. They are all constant. So find dv by dh because that is the only independent variable here. And what will you get? You will get pi r square is pi r square minus 3 pi by 4 h square. Now, how do we find the critical point? For finding the critical points, what do? We equate this to 0. So that means you will get r square is equal to 3 by 4 h square. Or in other words, h will be 2r by root 3. So that means this is the point where this is the critical point of the V. But then, is this critical point the place where V gets the maximum value? That we have to check. How do we check? We check that by taking the second derivative of V, and that will be what? That will be minus 3 by 2 here 2 minus 3 by 2 pi h. Now this is clearly negative. So that is good news for us. So what does that mean? That means in this critical point, your volume becomes maximum, and that is exactly what the first question is about. So we are saying that if the volume is maximum, the condition that has to be satisfied is that the height of this cylinder has to be 2 by root 3 of the radius of the sphere. Now you come to the second question. That is also a follow-up on this question. The question is, what is the maximum volume? You know that the volume is maximum when h gets this value. But then what is that maximum volume? That will be pi r square h. Express everything in the terms of the radius of the sphere. So pi h we have found out as 2 by root 3 r, and r square come here, then r square will be 4 by 3 r square. This is h square, and then a by 4 here, so that would be cut. So that would be r square is equal to r square minus r square by 3. That means 2 by 3 r square. Putting it here, you get, okay, so you have 4, 3 root 3, a pi, and an r cube. So again we are considering two different shapes. So this time it is a cone. You have a cone, and what is given? The height of the cone is given to be what? H. And the semi-vertical angle is given as alpha. So these two are given. So whenever you hear the word given, remember that you cannot touch that, it is fixed. So now we are going to inscribe a cylinder inside this cone. So the cylinder will also have a radius, and the cylinder will also have a height, right? So the cylinder's height we will take as h, and the cylinder's radius we will take as capital R. So what do we need? We need the volume of this cylinder to be maximum. So what is the volume of the cylinder? It is pi r square h. So as usual, you have what? Two independent variables. So we need to get rid of one of them. So let us get rid of this height. How do we do that? What is the total height? The total height of the cone is h. What is the height of the cylinder? It is only this much. So consider this distance. You see this distance here? So the height of the cone is height of the cylinder plus this much. Let us name this as O, O dash, and I will name this as, say, P. So now consider this small triangle. What is that? O, O dash, P. So I have named these points O, and this is O dash, and this is P. So the whole height of the cone is equal to the height of the cylinder plus this O dash. Now this is where you have the semi-vertical angle, right? This is the semi-vertical angle. This is O dash, and we know this to be R. Can you find some formula which connects all of that O dash, this angle, and this side? What about tan alpha? Tan alpha will be what? Tan alpha will be opposite side by adjacent side. So instead of O dash, you can write R by tan alpha. Now that is what we are going to substitute here. Pi, keep R square as it is, and instead of h, write this one. H minus R tan alpha. That would be what? That would be pi r square h minus pi r cube by tan alpha. So therefore, what have we done here? We have got this volume just in terms of one independent variable. We have got rid of the height of the cylinder and we have expressed the volume of the cylinder just in terms of its radius. Rest of all are given. H, alpha are all fixed. Pi is fixed. H alpha is all fixed. Only r is the thing which keeps changing. So we find dV by dr, that will be 2 pi r h minus 3 pi r square by tan alpha. As I said before, these are all fixed, these are all constant. None of this changes. Now we have to find the critical point. How will we find the critical point? By equating this to 0. So let us do that. Let us equate dV by dr is equal to 0. So pi is common, r is common. So you get 2h minus 3r by tan alpha. Now you have the product of two numbers. Either this is equal to 0 or this is equal to 0, but pi r cannot be 0. Why is that? Because r is a radius, it cannot be 0. So this is not equal to 0. The only option would be this is equal to 0. That would mean 2h is equal to 3r by tan alpha, or in other words, r will be equal to 2h tan alpha by 3. I've removed the calculations so that you can focus on what is happening here. We found the first derivative and equating it to 0, we got the critical point. But then in that critical point, how do we find whether the volume is maximum or minimum? We have to find the second derivative. Then we found for this we got the second derivative. So this term, this is with respect to r. Remember, we reduced everything to r. So this became 2 pi h and this became minus 6 pi r by tan alpha. But then what is r? R is 2h tan alpha by 3. So substituting it here, we got the second derivative of v to be negative. We found it to be minus 2 pi h. So it is good news. So that means at this point, the volume of the cylinder is maximum. But then the question is, what is that volume? So v is equal to pi r square h. So instead of r, substitute this. Square it. 4 h square by 9 tan square alpha. And what is this capital H? We have expressed this capital H, which is the height of the cylinder, the smaller height, in terms of the height of the cone and this OO dash. So this is what you have. So out of this, what will be capital H? Capital H will be small h minus r by tan alpha. But then in this tan alpha, if you divide tan alpha out of it, what do you get? You get 2h by 3. So h minus 2h by 3 will be h by 3. Multiply both, what do you get? You get 4 by 27 pi h cube tan square alpha. Now this is not the only question. There is another question. And what is the second question? We got the maximum volume. That is fine. But for that maximum volume, how much should be the height? Is it this much? Is it this much? How much does the h has to be if v has to be maximum? So what is h here? Again, we found out what h is. So the capital H is equal to what? Small h minus r tan alpha, which is just h by 3. We have already found it. So this is our answer. So far, what have we done? We have taken two figures and tried to fix one into the other so that we get maximum area or maximum volume. But now these two questions are different. You have only one figure here. You have only a cone here. And what is the difference? What is given is the difference. In the first question, you have to keep the surface area as it is. You should not touch the surface area. But then you have to express the volume in terms of the surface area. Look at the next question. Here what is given? The slant height is given. So you have to keep the slant height as it is. Do not touch it. And then express the volume in terms of the slant height. So that is the main difference between these two questions. What are we keeping as a fixed value? So we will start with this. So what will we keep as fixed? The slant height. Do not touch it. So now this is the radius, this is the height, and what is the volume? Volume is pi by 3 r square h. So as usual, what do you have? You have two independent variables. From here, from this picture, you can see that applying the Pythagoras theorem, you can get r square. So leave h as it is. So what will be r square? It will be L square. This is L, right? This will be the hypotenuse. So L square will be R square plus H square. So R square will be L square minus H square. So just substitute it here. Pi by 3 L square minus H square by H. That will be equal to pi by 3 L square H minus pi by 3 H cube. Now find the derivative of V with respect to the only independent variable, which is H, and that you will get as pi by 3 L square minus this will be 3H square. 3 and 3 will get cancelled and you will get pi H square. To find the critical point, we equate dV by dH to 0. So you will get L square by 3 is equal to H square. That is, L square will be equal to 3H square, or in other words, L is equal to root 3H, or in other words, your H will be L by root 3. Now, if H is L by root 3, then what will be R? H square will be L square by 3. So, R square will be 2 by 3 L square. That will be, so you will have R to be root 2 by root 3 L. Derivative, the derivative of the second order. This whole thing becomes 0 because there is no H here, and this becomes minus 2 pi H, which is clearly less than 0. So volume is maximum when these two, when H has this value and R has this value. But then our concern is not about the volume. We can substitute this here and we can get the maximum value. That is not the problem. Our problem is about the semi-vertical angle. What is the semi-vertical angle? We have found what it is. This was H. This was our R, this was the height, this was the radius. Now, how have they expressed the semi-vertical angle? They have expressed it in terms of tan inverse and cos inverse. So, find cos alpha and tan alpha and then take the inverse. So, what do you have? What do you have for tan alpha? It will be opposite side, which is radius, by adjacent side, which is H. But then what is your radius? It is root 2 by root 3 L into what is H? Take the reciprocal, root 3 by L. It is, so therefore alpha is tan inverse of this. But you always but then you also have to find cos alpha. That will be what? Adjacent side, which is the height, by the hypotenuse, which is L, but height is what? L by root 3 into L, cut. That will be 1 by root 3, or in other words, cos alpha. If cos alpha is 1 by root 3, alpha will be cos inverse of 1 by root 3. Now, what is the problem we have here? The second problem here, we took L as a constant and we solved the problem as if L was a constant. But then in the second thing, what do you have? You have the surface area as a constant. So you have to somehow include the surface area in the formula of the volume. Now what is the surface area of a cone? There you have your slant height. Here there is your height. Here there is your radius. And this is what? Surface area is area of this. That would be pi r square plus area of this region. That would be pi r l. Now this will be your constant. Don't even go near it. So next is you have to maximize the volume. How will you maximize the volume? What is the volume? Pi by 3 r square h. So here you have two independent variables. We have to get rid of that. Now r square, you see r square, it is there. So what about h? Instead of h, how can you put this surface area here? How do you do that? Let us see. Let the surface area be pi, so it will be pi r square plus pi r l. That means s minus pi r square by pi r is equal to the length. Now you have got the length, but then still you have to connect it to h, right? How do you connect it to h? See here, make the square of l square. Make the square of l. So you will get s minus pi r square, the whole square, by pi square r square. This is your l square. So h square plus r square is equal to l square. Here you have h square, but here you have only h. So what do? Square the volume, and no need to worry. Whatever points makes volume max, the same points will make the square of the volume also max. So volume square is pi square by 9 r raised to 4 h square. Instead of this v square, take it as x. So you have x is equal to pi square by 9 r raised to 4 by h square. What is this h square? It is this whole of l square, right? This is l square minus r square. Why is that? From the Pythagoras theorem. But then what is l square? From here, what is l square? It will be s minus pi r square by pi r the whole square minus r square. Got it? So now let us open the brackets. 9 r square the whole square. This will be a pi square and this will be an r square. If we take it here, you will get minus pi square r raised to 4 the whole by pi square r square. So here you see, here you have cut this, and what will be left? An r square by 9. If you cut this and cut this, an r square by 9 will be left, and inside the brackets what will be left? Okay. So now r square by 9, there will be an s square, there will be a, this is a minus b the whole square, right? There is an a square term, there is a minus 2ab term, that is 2s pi r square term, and then the square of this. The square of this will be what? It will be pi square r raised to 4. That is exactly what we have here. That too will get cancelled. So this becomes your x. So the square of the volume is this. So what do you have here? You have x expressed only in the terms of one independent variable. We have got rid of this h. Instead, we have substituted it with something which is constant, s, which is constant. So this is your x. So how do you find its critical point? Find its derivative. Its derivative would, with respect to r. So its derivative will be what? Its derivative will be 2rs square by 9 minus 4 into 2 would be 8 by 9 s pi r cube. To find the critical points, equated to 0. So what all will be common there? 2 by 9 will be common, 1 s will be common, and 1 r will be common. So therefore you will have s minus 4 pi r square. That means either this is equal to 0 or this is equal to 0, but this cannot be 0 because both the surface area and the radius are non-zero. So you will get s is equal to 4 pi r square. So in this equation, if we substitute 4 pi r square, we got 3 pi r square is equal to pi r L. So solving that equation, we got L is equal to 3r. If L is equal to 3r here, then h square is equal to what? 9r square minus r square, which is 8r square. So finding its square root, we got h is equal to 2 root 2r. So these, at the critical point, these are the values. But then, is that critical point the maximum? For that we find the second derivative. This is what we got this, the second derivative with respect to r. This became, the first term got 2s square by 9. The second one became 8 by 3 s pi r square. But then, what is s pi r square here? S is equal to 4 pi r square. So you have a pi r square term here, and from here you can get a 4. So 4 pi r square is actually s. Substitute that value here and you will see that the second derivative is, you will get the second derivative only in terms of s square, and you will find that it is a negative number. So what does that mean? That means at this point the volume of the cone is actually maximum. But then that is not the question. The question is, what is the semi-vertical angle? Semi-vertical angle is sine inverse of what? So what is sine alpha? Opposite side by hypotenuse. At the critical point, what did we find L was? So alpha is sine inverse of 1 by 3. We come to the last question. We have been dealing with curved figures for so long. It would be unfair if we don't address the polygons. So that is what our last question is about. It is about a rectangular sheet whose length is 45 centimeter and whose breadth is 24 centimeter. Now this is a rectangle. It cannot hold anything. I want to make a box out of it, a cuboid. So what do? I cut off the corners, all of the same length. From each corner, I cut off a small square of side x. And then what do? Then I raise up the flaps like this. Then what do you get? You get a cuboid, right? You get a box. What will be the length of the box? This much length is 45. But then the new length of the box that I have made, what is the new length? It would be 45 minus a x here, a x here. So it will be 45 minus 2x. Similarly, what will be the breadth? It will be 24 minus 2x. And what will be the height? That is the difference between a rectangle and a cuboid, right? So it has a height. So that height will be what? If I raise the flaps like this, you will see that that height is x. So what will be the volume? Volume is L into B into H, or in other words, x into 45 minus 2x into 24 minus 2x. Now we have got the volume. Our question is, what should be the value of x so that this volume is maximum? Or in other words, how much should we cut here so that the box that we have has maximum volume? And how do we do that? We find the first derivative, equate it to 0. That will give us the critical points. Now what is the first derivative? The first derivative is equal to 12x square minus 2. So this will be the first derivative. To find the critical points, equate it to 0 and you will get x is equal to 5 and 18. The question is, you have two values. At which value is V maximum? For that, what do? We find the second derivative, which is this will be our second derivative. That is, find the value of the second derivative at x is equal to 5. When you put x is equal to 5, you will see that d square v by dx square is actually less than 0. It is negative. That means what? At x is equal to 5, volume will be maximum. What happens at x is equal to 18? Substitute that and you will see that the second derivative is actually greater than 0. Which means if you want maximum volume, you have to cut off squares of side 5 from all the 4 corners. So with this we come to the end of this topic. Till we meet again, take care. Assalamu alaikum.